Hey guys, welcome back to the channel. If it's your first time here, we go through math and physics tutorials, as well as how to improve the psychology of a student. In this video, we're going over analytic geometry and classifying quadrilaterals. I'll be going through the various characteristics of quadrilaterals, as well as how to use diagonals to define them. This is part 3 of the 3-part series related to analytic geometry, where we went over circles, triangles, and now quadrilaterals. By the end of this video, you'll be able to classify a quadrilateral as either a parallelogram, rectangle, rhombus, square, trapezoid, or kite. If you find this video helpful, please like this video and subscribe to the channel to see more videos just like this. Stick around to the end of this video to learn the best tactic for studying for longer periods of time. So let's go over the characteristics of quadrilateral. A quadrilateral is a polygon that has 4 sides. There are various groups and shapes that each quadrilateral can fall into, and many of them fall into more than one. Take a square for example. It has the characteristics to be classified as a parallelogram, rectangle, and a rhombus. But it doesn't work the other way around. Just because a square is always a parallelogram, that doesn't mean that a parallelogram is always a square. Before we define these shapes, let's first go over what a diagonal is. So a diagonal for a quadrilateral is a line that connects one vertex to its opposite vertex. So this would be this orange line here for this rectangle. So the shapes that we're going to be going over are a rectangle, rhombus, square, parallelogram, trapezoid, and kite. For a parallelogram, the characteristic that defines it is that the diagonals bisect each other. And what that means is the midpoints of this green diagonal and the midpoint of this blue diagonal are going to be the same. And that's basically saying that these at the intersection point, the diagonals create a equal length line on either side. For a rectangle, the diagonals do bisect each other as well, and these diagonals have the same length. For a rhombus, they don't have the same length for these diagonals, but they bisect each other and the diagonals are perpendicular. So that green value, or the yellow line and the orange line, are perpendicular to each other. Finally, we have a square, and this is where all the characteristics are kind of defined into one. So we have the diagonals bisect each other, we have the diagonals have the same length, and these diagonals are perpendicular. So this is why a diagonal or a square can be defined as a parallelogram, rectangle, or a rhombus, because it matches all 3 criteria, and only when all 3 are met, then it's defined as a square. For a trapezoid, we actually don't use diagonals, but what we do know is that a trapezoid has one set of parallel lines. So these 2 lines here are parallel. And what we do is we test all of our other criteria for the diagonals being bisecting each other, being the same length, or being perpendicular. And if it fails all of them, but still has one parallel line, that means that it's a trapezoid. And lastly, we have a kite. And for a kite, the diagonals do not bisect each other. So this green line and orange line, they do intersect, but they don't create equal length lines on either side of them. So they're not bisectors. Additionally, the diagonals actually are perpendicular for a kite. So we have this green line and orange line form a right angle here. So for our first problem, we're asked to classify this quadrilateral. We have these points that were given, and then I connected all these points to form a quadrilateral. And what we do is we look at our checklist of things to check to see what we can classify it as. So first, do the diagonals bisect each other? So that means, does the line AC, or the diagonal AC, its midpoint, is it the same as the diagonal from B to D? So let's check. So the midpoint of AC is just going to be half in the x direction and half in the y direction. So I'm going to say is equal to, let's see, so 0 plus 8 divided by 2, and then it's going to be 0 plus 6 divided by 2. So the midpoint of AC is equal to 4, 3. Now let's check the midpoint for BD. So the midpoint for BD, or point B, or line BD, is going to be 5 plus 3 divided by 2, and then we're going to have 5 plus 1 divided by 2. So the midpoint of BD is equal to 8 over 2, so that's 4, and it's 6 over 2, so that's also 3. So here we have the midpoints of both diagonals match, so that means this situation, or this quadrilateral, can be classified as a parallelogram. Now typically we would check the other 2 criterias to see if it falls into either a rhombus or a rectangle, or even a square if it satisfies all 3, but to save length for this video, we're just going to move on because I know that this one actually doesn't have any other criteria to satisfy, and in the next problems we'll see other criteria that get satisfied. So now moving on to problem 2, we have another quadrilateral and we're asked to classify it. So first we're going to check to see if the diagonals bisect each other. So we're going to get the midpoint of AC again, and that's going to be 6 plus 2 is 8, divided by 2 is 4. So it's going to be 4, and then we're going to get 3 plus 5, that's 8, and that's going to be 4 as well. Now we can check the midpoint of line BD, and that will be 1 plus 7 is 8, divided by 2 is 4. 10 plus negative 2 is 8, divided by 2 is 4. So here, again, we have a midpoint that matches the other midpoint of the diagonals. So now we can conclude that if the midpoints match, that means that the diagonals actually bisect each other, and therefore this is a parallelogram. So now let's check the other criteria of, are the diagonals the same length? So for this one, we'll do AC, and this is going to be Pythagorean theorem. So if I were to write the same length, trying to find the same length of this diagonal, what I'm really doing is finding the hypotenuse of this triangle. So this line right here. So now what we can do is we can go in the x direction, have that distance squared, go in the y direction, have that distance squared, and that will equal our hypotenuse squared. So there is like a distance formula, but the formula really is just Pythagorean theorem. So I'd encourage you to kind of work your way through looking at it this way as opposed to memorizing that formula or using that formula constantly. So here we have AC is going to equal, or the length of AC is going to be 5, I guess we'll do the x's first. So we can do 6 minus 2 squared plus, then we're going to do 5 minus 3 squared. And all that is square root. It's under the square root. And AC is going to be, well, 6 minus 2, that's 4. So 4 squared is 16. Plus 5 minus 3 is 2. So then 2 squared is 4. And that's all under the square root. So we're going to get line AC to equal root 20. Now we're going to do the same thing for line BD. So for BD, we have the length is going to be, what was it? Point D is 110. So we're going to say that the x distance is 1 to 10. So it's going to be 7 minus 1 squared. And then plus, or sorry, not 1 to 10, 1 to 7. And then it's going to be negative 2 minus 10, and that's squared. So the length of line BD is going to be, well, that's going to be 36. 7 minus 1 is 6. 6 squared is 36. Plus, and then it's going to be negative 12 over here. That squared is 144. So the line of BD is going to equal 36 plus 144. It's going to be the square root of 180. So now line AC and line BD don't match. So we know that the diagonals aren't the same length, and therefore this is not a rectangle. So we've now passed this test, or the first test here, failed this test. Now let's check to see if the diagonals are perpendicular. So for them to be perpendicular, I'm going to get the slope of line AC, and that's going to be the rise over the run, so it's going to be 5 minus 3 divided by, and then we'll have 6 minus 2, so that's going to be 5 minus 3 is 2 over, and then 6 minus 2 is 4. So it's going to be 1/2 is the slope. And so if these lines are perpendicular, or the diagonals are perpendicular, what's going to happen is the slope of the other line should be the negative reciprocal of this line. And the negative reciprocal is just switching these two, the numerator and the denominator, and putting a negative in front of it. So I'd expect, if they are perpendicular, that line BD to be negative 2 over 1. So let's check. Slope BD is going to equal, so rise over the run, so it's going to be negative 2 minus 10 divided by 7 minus 1. So that's going to be negative 12 divided by 6, and that's negative 2. So here, and you could say negative 2 over 1 if it makes it a little easier. So here, we actually find that the slope of AC is the negative reciprocal of BD. So that means that they're perpendicular. So we passed this test, and now we can conclude that this shape here is a rhombus. Okay, for problem number 3, we're going to do the same kind of thing. We're going to go through this checklist of things to see what satisfy which criteria, and then we can conclude what type of quadrilateral it is. So we're going to find the midpoint of AC, and that's going to be 1 plus 5 is 6, divided by 2 is 3. Then we're going to do negative 2 plus 5, that's going to be 3 divided by 2, so I'll just write 3 over 2. Now we'll do the midpoint of BD, and that's going to be 7 minus 1, so that's going to be 6, divided by 2, that's 3. And then we'll get 1 plus 2, well that's 3, and then that's going to be 3 divided by 2. So again, we get the midpoints to be the same value, meaning the diagonals do bisect. So at the very least, this quadrilateral is a parallelogram. Now let's check to see if the diagonals have the same length. So we're going to do AC is going to equal, and it's going to be the x distance, so 5 minus 1 squared plus, it's going to be the y distance, so it's going to be 5 minus negative 2, and then that all squared, and then the square root of that. So we're going to have AC is equal to 5 minus 1 is 4, 4 squared is 16, plus 5 minus negative 2, that's going to be 5 plus 2, so that's going to be 7, 7 squared is 49, and that's all going to be under the square root, and we'll have that line AC is the square root of 65. Now let's check for line BD. So for BD, we're going to have the x distance, so we'll say 7 minus negative 1, and then that's squared, plus we'll have the y distance, 2 minus 1, that's squared, and then all under the square root. So BD will be 7 plus 1, so that's 8, and 8 squared is 64. And then 2 minus 1, well that's 1, and 1 squared is just 1. So plus 1, and then BD is going to be root 65. So now, length of AC and the length of BD, so the length of both diagonals, were equivalent. So we can say that this is a rectangle. Now again, to save time on this video, I know that these diagonals are not perpendicular, but we showed it in the last one how to do that. So you would check this checklist to make sure that this was not perpendicular, because if it were, then all three of these would be satisfied, and that would make this quadrilateral a square. So now I want to talk about the best way to allow yourself to study longer. This isn't a quick fix, but it does work. Your brain will be able to focus longer the more consistently you train it to focus longer. There are ways to make this more pleasant though. When you find yourself studying and you're not retaining the information as well as you once were, take a quick 5-minute break. If you're following my last tip in the last video, turn off your study lamp and walk away from your study environment for 5 minutes. This will make your brain come back more fresh, and it will allow you to not resent studying as such a boring or grueling activity. Once you give yourself some slack and allow yourself to have a quick break, it makes studying for longer periods of time a lot easier. The more you do this, the better you'll become at studying for longer periods, and the more effective and efficient your study time will be. Thank you for taking the time to watch this video. If you guys like this content, I'd really appreciate you liking this video and subscribing to the channel to see more videos just like this. I make a ton of content to help in math and physics, as well as improve the confidence and psychology of students. If you have a specific topic you want me to cover, let me know in the comments below. Thanks again, and I'll see you guys in the next video.